how to find the mean. So measures of central tendencies. So remember, that just means analyzing the center of the data. And there's different ways of doing that. So mean means average. You could also call it X bar. That's just the notation. So mean means average. Once again, remember if I said find the mean, remember you say, oh yeah, that means average, because if you called me an average student, that's mean. So if for example, if this set right here, this particular set, I summed up all of those, divided by the total number of terms, 16 over 6. So our average of this is 2.6. Is everybody good with that? Then we found our median, which means middle. So median means middle. So I went in 1, 2, 3. So it meant the middle. So I added those up, that's 5, divided by 2, right? So our middle of this data set is 2.5, right in between here. Oops, yeah. And then our mode happens most. The one that happens most in here is 1. Remember, there can be bimodal data sets, which means 2 modes. Anything more than 2 modes, the mode doesn't affect our statistics. Then range means spread. How much is this spread? Where does it range between? So this is between 1 and 5. You do your max minus your min. So it ranges over 4. This data spreads over 4. Is everybody comfortable with that? It's spread over 4 units. And then remember, interquartile range, still a range, but it's the interquartile range. We learned how to find Q3, Q1. So remember, Q1 and Q3 are just the medians of the upper half and lower half of the data set. So we found the actual median. It was 2.5, right? So then we found the median of the lower half. So below that was 2, 1, 1. So I went in and it was here, right? So that'd be Q1. And then we found the median of the upper half. So 3, 4, 5 would be 4. That's Q3, the median of the upper half. So the interquartile range is Q3 minus Q1, 4 minus 1, which is 3. So the middle is ranging between 3. And then we learned how to do a box and whisker plot that showed the spread. Remember, a box and whisker plot has a min and a max as the whiskers. And then this is Q2, which is the median. This is Q1, the median of the lower half, and Q3, the median of the upper half. Now notice, this one I'm going to fix this box and whisker plot, because see how the lowest value is 1? Everybody pay attention so that you can know how to do this right. The lowest value is 1, and also isn't Q1 1. So you would actually not, I drew this on purpose like this, because usually a box and whisker plot will have a min that's not the same as Q1. But if it did, we wouldn't write 1 twice, because we're just graphing this on like an XY chart. So the whisker would be also the, yeah, you're missing a whisker, and that's okay. Okay, is everybody good with that? Okay. So then, remember we learned about percentile. Really important. It's easy, but you have to know what you're doing. So remember, percentile is a number that represents the percent of values that are at or below that value. So what's the 60th percentile? So remember, 60th percentile means 60% of the data is at or below that. So we've got to count up our total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points, right? 10 total. So then 60% of that would be 10 times 0.60, right? Which is 6. So it says, what is the 60th percentile? So that would be at 1, 2, 3, 4, 5, 6 right here, right?
So they have to be in order.
Yes, they would have to be in order. Good point. So that was one thing I didn't say, but yes, percentile would need to be in order from least to greatest, and it won't always be. Oftentimes it won't be. So you'll put it in order, and then the data, 60% of the data is at or below 4 in this data set. So we said we would say 4. And then right here, so, and then if we changed and said what values are at the 60th percentile values, we would have contained all of those, right? Just depends on the wording of the question. Now I'm asking it differently just for practice. What percentile is 5? So we've got to go backwards. So let's see, we have it in order. 5 was here, right? So then how many data points was that to get there? 7. So wouldn't that be 7 out of 10?
Yep.
So that'd be 70th percentile, right? Because that was 7 out of 10. So if it was 7 out of 20, it wouldn't be 70, right? Does everybody get that? 70th percentile. Okay, sweet. All right, so then we learned about standard deviation. Remember, standard deviation is how far a value deviates from the mean. So how far a value deviates from the average. So the more it deviates, the further spread out your data is, right? Okay, so then with this, we learn how to find the standard deviation using our calculator. So let's go ahead and do that. Let's find the standard deviation using our calculator real quick for practice. Today's lessons is really easy, so that's why it's good to review everything. So take our calculator, and then you go to Stat, and then remember in List Stat Edit, and then in List 1, you type in those values. 1, 1, 2, 3, 4, 5. In List 1, type in those values, and then once you've done that, you hit Stat Calculate one variable statistics. So what I need is X bar, which means the average, and I need sigma, which means standard deviation. So tell me, ready, set, go. So 2.6 is found at one decimal place, so you said 2.63?
I said repeating.
Repeating, so that would be 2.7, right?
Yep.
Awesome, so 2.7 is our average of this data set, and what's our standard deviation?
You want the whole decimal?
Yeah.
No, because we're not gonna, I'm not asking variance right now.
1.5.
2.5, okay, awesome. 1.5, sorry, I can't hear. Okay, so let's think about it. I'm not actually going to place this in here right now. I'm just going to do it like this, because to me, I don't mess up so much. So we know our average is 2.7, right? So one standard deviation above and below. So one above, one below. So we take 2.7, add 1.5. What do we get? 4.2. Okay, sweet. Let's go to 2 standard deviations while we're at it. So what would we be at? Add that again, 1.5.
5.7.
Sweet, let's go one below. So 2.7 minus the standard deviation.
1.3.
1.2?
Yeah.
And then let's go one standard deviation below that. Another second standard deviation, 2 standard deviations.
-0.3.
Negative 0.3. Okay, so I'm looking at this, okay? So now let's answer this question here. So I've gone within 2 standard deviations. We could keep going if we needed. I'm just going to erase this. Okay. So the question is, within how many standard deviations does this data fall? So let's see, does one fall within, it falls within 2 standard deviations for sure, right? Okay, because 1 was in the second standard deviation, right? So we're good. 2 is obviously in between 1 standard deviation. 3 is up here, right? Within 1 standard deviation. 4 is also within 1 standard deviation. 5 was within 2 standard deviations. So all the data fell within 2, right? Is everybody comfortable with that? So we say 2. Okay? Now remember, let's think about it. If we had an outlier, wouldn't we probably have to go quite a few standard deviations to reach it? So that's why, they ask us, so what will happen with standard deviation and outliers? How does it relate? Well, if you think about it, an outlier would have taken many standard deviations. So it's many standard deviations away from the average. An outlier, right? Okay. Remember, outlier will affect our data set at extremes. Remember how I said, you're not right liar because it makes your data look different than it is. Okay, let's get going with what we're doing today. Today is actually pretty easy in a sense, but pretty hard in a sense, because I like math because there's always a right answer. Today there's not going to be an exact right answer. It's going to take your best judgment, and sometimes your best judgment might not be the correct best judgment. So it's just the very best judgment. So we'll do our best today. We'll just work together here, okay? So, first of all, we do need to know what some things mean. So, samples and surveys. So, first of all, we have to understand some notation. So, a population, that's what we're going to talk about first. By definition, a population is all the members of a set. So, make sure you don't say in your mind, when I first was doing statistics, I was thinking population as like world population always. That's not always the population. So population is just all the members of a set. The set could be world population. An example of a set could be the population of RHS students. Does that make sense? So population is not really world population necessarily. It's just the population, all of the members of a set. Okay, so then a sample versus a population. A sample is a part of the population. So once again, a sample is just a smaller part of the population. So if you determine a sample carefully, the statistics for the sample can be used to make general conclusions about the larger population. Because for example, if I wanted to know how many students across the world like math, there's an unlikely chance that I'm not going to obviously be able to survey or talk to every student in the world, right? So I'm going to have to come up with, instead of using the population, I'm going to have to come up with a sample, and then if I come up with a good enough sample, I can make general conclusions about the population. Does that make sense, everybody? So population is a whole, and then a sample is just a smaller piece of the population. If we select that sample smartly, we can make general conclusions about the whole population. Does everybody understand population versus sample? So here's what just to get it straight in your head, some examples of some populations and sample. Everything could be different. So here's an example of a population. People in the United States of America. A sample, a smaller piece, would be people in Utah. Does everybody see population versus sample? And then population, RHS students, that could be a population, and then a sample would be, for example, our class. You're a smaller piece of the whole school, right? Population, here's another example of population, our class. Okay, our class. Now here's an example of a sample of our class, Wyatt and Garrett. I just saw you two, I don't know, yesterday. Okay, so, does everybody see the example here? Okay, and then population, for example, could be fish in a pond. So an example of a sample could be trout in the pond. Okay, so these are the different types of sampling methods. Now you guys have this on your notes, like on your little paper I gave you. So refer to that, put some notes in there if you need to. Okay, so there are different types of sampling. The first one is a convenient sample. So a convenient sample, you guys do have to get these in your head, so really try to make sense of these with me, because I'm probably not going to let you use this on the test. Okay, so but really a lot of them make sense. So it says, a convenient sample, you select any members of the population who are conveniently and readily available. So an example of a convenient sample, for instance, if I was sampling, let's say the population was the RHS student body. Wouldn't it be really convenient for me to choose you people as my sample because you're in my class? Right? Okay. So convenient sample, you select any members of the population who are convenient and readily available. Then there's also a self-selected sample. This is when you select only members of the population who volunteer for a sample. So for instance, if you have ever seen like on TV, it says call in if you like feel like, for example, let's see, what's a real example that I've seen? Call in if you feel strongly about not having Donald Trump for president. Or that's me choosing to call in, right? They're only going to get the people that choose to call in. Does that make sense, everybody? So a self-selected sample, you're choosing to call in or fill out the survey. Then next thing, for a systematic sample, so these are all different. A systematic sample, this is important. You order the population in some way, and then you select from it at regular intervals. This is actually a pretty good way. So, for example, if I said I'm going to sample every fifth person. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That would be systematic. Does that make sense, everybody? Systematic. That makes it pretty dang random, for the most part, as long as you have a big enough sample. And then a random sample is actually usually the best. Because random means all the members of a population are equally likely to be chosen. So it's completely random. Everybody's equally likely to be chosen. So obviously this is a favorable type of sample. So samples vary in how well they reflect the population. So just because I picked a sample and said, okay, so let's say I wanted to know how many students absolutely love math in this school. And I only sampled you guys. Probably not the best type of sample because I can't make a general conclusion and say, well, all students at RHS love math because I know you guys all love me. But does that mean in general that math is loved in RHS? No. So you get what I'm saying, everybody, because that would be convenient, but that would not make me be able to make general conclusions about the population. Okay, so a sample can have a bias when a part of the population is overrepresented, which makes sense, guys. You guys are biased. If I just choose you guys because you're convenient, and I say, students love math at RHS. Well, it's probably a biased opinion because, I mean, I'm awesome, so you guys love math, but that might not be true necessarily. That's just an example across the board. Does that make sense, everybody? Okay? Awesome. So another example is what if I was to say, how many people eat school lunch and like it? Well, if I stood down at the cafeteria and asked the people that came in, do you like school lunch? Wouldn't that be a biased opinion? Because I'm asking the people who eat it. Do you get where I'm coming from with bias? Okay. Sweet. Okay, so here's some examples so you can get an idea of each type of sample. Because it kind of is hard if you don't see a few examples. Okay, so the first example here, a newspaper article on tax increase invites readers to express their opinions on the newspaper's website. So let's read this again. Really think about it so it can make sense to you when you do it yourself. So it says, a newspaper article on tax increase invites readers to express their opinions on the newspaper's website. So this is a self-selected sample, right? Aren't the people having to choose to go onto the website to express their opinion?
Yeah.
Okay, so then it might have a bias depending on who visits the website. The people who respond may overrepresent or underrepresent some views. For example, some property owners who are against tax might organize a campaign to get friends and neighbors to visit the website. Okay, so just that was an example. Does everybody understand why it was self-selected? Okay, next one. A reporter interviews people from leaving the city's largest park. So read it again. A reporter interviews people leaving the city's largest park. This would be considered a convenient sample. Okay, so it's convenient for the reporters to stay in one spot, right, and just sit and interview people. Does everybody understand why it's convenient? Okay, and then because the location is near the park, the sample may be overrepresented park supporters, and the results may have a bias. All right, and then in C, a survey service calls every 50th listing from the local phone book. What kind of?
Systematic.
Yeah, it'd be systematic, right? Every 50, every 50, every 50 you call. And then it might have a bias because if there's some link between people who are listed in the phone book or not listed in the phone book, might have an opinion, one stronger than the other, in paying property taxes. Okay, so let's answer these two and I'll let you go. So, to survey the eating habits of the community, employees of a local television station interview people visiting a food court in the mall. What kind of sampling method are they using, and does it have bias? So let's look at our sampling methods. A survey, it's convenience, right, everybody?
Yeah.
Isn't it convenient? Isn't that convenient to go and sit and ask people all in the same spot in the local mall? Okay, convenient. Okay, so it's a convenient sample. Now, what kind of bias might we see with this?
He's just asking people at the mall.
What was that?
He's just asking people at the mall, so it'd be like,
That's a great one. So it could be just mall people, right? And another one I thought of, aren't those people, if they're eating at the mall, they're obviously willing to eat out, right? So couldn't it overrepresent fast food eaters?
yes.
Okay, so everybody's good with that, right? So I'm not going to write that down. You're good to go. Now, a poll of every person in the population is a census. What's a situation that requires a census instead of a sample? So, you know how we just talked about we're sampling just pieces of the population? A census, by definition, is actually interviewing or talking to or polling every single person of a population. So you guys think about it for a second. What's a situation that requires a census instead of a sample? Now remember, population doesn't need to mean the world population, right? Population can be many things. So ready, set, go.
Elections.
But do elections, does everybody vote? That's one that's actually usually said. But not everybody's votes, right? So that wouldn't be necessarily a census. Yeah?
I need that population gathering.
What was that?
I can't remember, but there's like population census where they go around finding those.
Yeah, that's a really good one. I never thought of that. So there are population census because they need to know an exact population of Utah, for example. So they go, I don't know how they do it, but they could go to get birth certificates, right? For anyone that's been born in Utah, you know what I mean? Add those up, right? Does that make sense? Another one I thought of, let's say the population of the school. Wouldn't it be a census for everybody in year 2017 to get their schedule done? Wouldn't every single person have to get their schedule done for next year? Like, that would be considered a census. Because there's no one that doesn't get a schedule done from that population. Okay. Do you need a few more, maybe?
No.
You're sure? You're sure? Because sometimes you might think you get it, and then...
Yeah. I did this in the job,
So we're ready to go. You don't need any more. You can get them right. So, raise your hand if you want maybe 2 more quick examples, and then go. It's not like it's that hard. It would probably be worth it. No? Raise your hand. So no one raised their hand. Wait, raise your hand. Don't be afraid. If you want 2 more quick examples.
Oh.
Awesome. Let's go through these. Okay. So identify the sampling methods and identify the bias. So quick, guys, but it's really good to see these. If I don't, sometimes it's really hard. So it says a supermarket wants to find the percent of shoppers who use coupons. A manager interviews every shopper entering the greeting card aisle. What kind of sampling method? There's only one for this one. Good. Convenience, right? Isn't that convenient to stand in the same spot and hand out anyone who walks into the greeting card, okay? So this would be convenience. what bias would we have?
He's only getting people that walk by.
So he's only interviewing people that are going into the greeting card aisle. So it might overrepresent people who are buying greeting or buy cards, right? Everybody, do you see this? Okay, so in the next one, a maintenance crew wants to estimate how many of 3,000 air filters in a 30-story office building need replacing. The crew estimates 5 filters chosen at random on each floor of the building. What kind of sampling method is this? What was it? That's what some people would want to say for this one. What is it? Nope. That's actually a common one. It's systematic. See, these are some tricky, right? So this was systematic, right? Because aren't they going? If it was random, they'd just be randomly selecting, not selecting 5 on the floor, 5 on the floor, 5 on the floor. Does that make sense, everybody? Right, but it's still every, like, random would just be random, everywhere random. You know what I mean? So good, but this one would be systematic.
How many?
Which, guys, this actually, systematic is usually pretty good. As long as you get enough, systematic is almost as good as random. So it says, so really there wouldn't be a bias in this one. This would probably be okay. Does that make sense, everybody? Okay, sweet. I can't think of a bias for that, really. Okay. So, as long as the sample's big enough. Do problems 1 through 3, then we'll continue. So moving on. So, once you figured out, okay, so we have a population. We obviously not all the time can interview or talk to the whole population. So that's why we've learned about selecting a sample. We've talked about what would be a good thing, a good way to select a sample, and maybe not the best, or what biases you might see. So there's convenient samples, there's self-selected, systematic, and random samples. Okay, so make sure you've got in your head which one's which. So once you pick a sample, now you've got to come up with a study. So once you pick a sample, it'll come up with a study, and there's different types of study methods. So the first one is an observational study. Listen, because a lot of you I don't think listened in this. Okay, an observational study. You basically sit back and observe the members of the sample in such a way that they are not affected by the study. So, for example, if I was looking and saying how many people actually work on math and I didn't do anything, I didn't say anything, I just sat down, took notes, watched. You had no idea. Does that make sense, everybody? That's just observational. Another one would be like people, you've heard of people going and observing wildlife in the jungle, right? They just go and observe. They don't do anything. Observational. Okay, then there's a controlled experiment. A controlled experiment, you divide the sample into 2 groups. You impose a treatment on one group, but not the other group. The group you do not impose in treatment is called impose treatment I'm not saying that right. Impose treatment on is called the control group. And then you compare the effect on the treated group versus the control group. So the control group doesn't get the treatment, and then the treated group obviously gets the treatment. So that would be splitting you in half. Boom, boom. And I say, I give you guys a test review. You guys don't get a test review. Then we take a test, and I compare. Does that make sense, everybody? So the people who did not get the test review would be the control group. Does everybody understand that? If I'm studying, for example, how well a test review helps. Does that make sense? Okay. So, controlled experiment, you're splitting it into 2. One gets the treatment, one doesn't. Control means no, the other is yes. Then there's a survey. A survey, you ask every single member of the sample a set of questions. So if you perform a survey, which is usually what happens, especially when dealing with people, then every single member of the sample gets the questions. Questions? So a poorly designed study can result in unreliable statistics. You should always, so it says you should always analyze a study method, you should always analyze a study methods, a study's methods, there we go, I can't read upside like looking like this. A study's methods before making general conclusions about the population. So if you're not careful about the type of study and you come up with a general conclusion based on that on that sample from the population, your study wasn't good, then you haven't come up with a correct conclusion. So you guys have that on your paper. Okay. So this is the cycle it happens in. First, you'll select a sample from the entire population by one of these methods. Second, you'll perform a study, observational, controlled, experiment, or survey. Does everybody understand the cycle that this goes in? So the first thing you've got to do out of the whole population is pick a sample. Ding, 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 ding. By one of these methods, right? Now that you've picked a sample, you've then got to perform a study, observational, survey, or controlled experiment. Is everybody comfortable with that? Okay, so like an example, for example, if I said, okay, the population's RHS students, I'm going to take a sample, and I'm going to randomly pick students, so I go out, I grab somebody from here, there, let's make it random. So I'm just grabbing people all over the school, randomly see them, grab them. I pull them into a room, now I'm going to perform a study. I choose to do a controlled experiment, so I say, you on this half, you on this half. You guys eat chocolate for a week, you guys don't. Let's see who gains weight. Does that make sense, everybody? Okay. All right, so a researcher, let's choose what kind of experiment's happening so you can get some examples. So a researcher randomly chooses 2 groups from 10 volunteers. Over a period of 8 weeks, one group eats ice cream before going to sleep, the other does not. Volunteers wear monitoring devices while sleeping, and researchers record the dream activity. So this is an example of a controlled experiment. Didn't half get it, half not. Okay, we're all good. And then the statistics for this study are based on such a small sample that the findings are unreliable to make general conclusions on the entire population. Okay, students in a science class record the height of a bean plant as they grow. So this would just be an observational study. They kick back and watch the plants grow. They don't do anything to the plants, they just sit and watch them. Does everybody understand that? That's just observing, right? Then making a conclusion. We're all good with those 2. Then the next one says, student council members ask every 10th student, so that's the systematic, right? That's not the study part. So it says, ask every 10 students in the lunch line if they like cafeteria food. So are they asking every 10th student the same question, right? Yeah. A survey question, right? Yeah. So this is a survey. The results are not reliable because people waiting in the line are more likely to enjoy eating cafeteria food than those who aren't in the cafeteria. Does everybody understand? You're sure? Okay. So, a pharmaceutical company asked for volunteers to test a new drug to treat high blood pressure. Half the volunteers will be given the drug and half will be given a placebo. They actually do tons of studies like this. The other day, they said on the radio, come get your bunion removed. And so then people will get their bunion removed and they're testing a new drug medication. So they, for free, move your bunion off your foot, which is like a big knob on your foot, and then half of the people they give a pain medication that's new, they're testing it. The other people they give a placebo. They tell them that it's the drug. So they come back and say, so how did it work for you? Does that make sense, everybody? Placebo is a drug that's not real. So they could be giving them Advil or sugar pills. Yes. Does that make sense? A different type of medication. So they don't know. They have no idea if they have the placebo or not. Okay, so then it says, which type of study method is the researcher using? Look at your little paper. It's a what kind of experiment? Controlled. They give half the pill, half the placebo pill. Are we all good with controlled? And then it says, should the sample statistics be used to make a general conclusion about the effectiveness in the drug in a larger population? Well, I mean, as long as it's a big enough sample, it might be okay, right? Yep. Okay. Okay, so a list of students is randomly generated from a school database. Information for every student is entered into the database, and each student has an equally likely chance of being selected. The students selected are asked how much time they spend on household chores. What kind of study method? If you can't tell me, then you didn't understand. So we're reading it. So a list of students is randomly generated from a school database. Information for every student is entered into the database, and each student has an equally likely chance of being selected. So this would be well, it's systematic, right? Every 10th student, but that's not, and then, so that's good, it's systematic, but that's not where it's being asked what kind of study. And so it says the students selected are asked how much time they spend on household chores. Which type of study? Surveys. Does everybody understand? Okay, next question. A gardener tests a new plant food by planting seeds from the same package in the same soil and location. Each plant is given the same amount of water, but half of the plants are given food and the other half are given no food. He records the growth of the flowering rates of each plant. So what kind?
No, it's not.
It's controlled, right? Are they giving half of it something and not? So observational, they would just sit back and watch, not do anything. Does that make sense? So this one's controlled. Okay, questions? The rest of the time, you're